somewhere in your pocket, on your desk, or inside the device reading these words right now, there's a chip designed by a company that has never built a single factory to make it. Apple designs its own processors. Nvidia designs the chips powering the artificial intelligence boom. AMD, Qualcomm, dozens of other companies whose names appear on the products you actually buy. None of them own the factories capable of physically manufacturing the chips they design. That manufacturing happens somewhere else entirely, at a company most consumers have never directly interacted with and whose name rarely appears on the box. That company is TSMC, and the reason so many of the world's most valuable chip designers don't own their own factories isn't an accident of the market. It's the result of one company deciding decades ago that the way to win in semiconductors wasn't to compete with its customers, it was to stop being their competitor entirely. To understand why that decision mattered so much, you first have to understand how the chip industry worked before TSMC existed. Because the old model wasn't broken in any obvious way. It was simply expensive in a way that was about to become unsustainable. For most of the history of semiconductors, a chip company did everything itself, start to finish. It employed the engineers who designed the chip's architecture. It employed the process engineers who figured out how to physically manufacture that design on silicon. And critically, it owned and operated the fabrication plant, the fab where that manufacturing actually happened. This is called the integrated device manufacturer model, and for decades it made sense, because designing a chip and manufacturing it were so tightly linked that separating them seemed almost impossible. The specific way a transistor is physically built on silicon constrains what a designer can even attempt to draw. A company that controlled both sides of that relationship could optimize each one around the other, tuning the design to exploit exactly what its own factory could do. But there was a structural problem embedded in this model, one that got worse year after year, in a very predictable way. Building a modern semiconductor fabrication plant is one of the single most capital-intensive undertakings in any industry on Earth. A cutting-edge fab today can cost tens of billions of dollars to construct and equip, filled with machines like the EUV lithography systems produced by a small number of specialized suppliers, each one of those individual machines costing well over $100 million on its own. And that enormous cost isn't a one-time expense you pay once and then coast on. Because chip manufacturing technology keeps advancing, smaller transistors, new materials, new techniques, a fab that's state-of-the-art today becomes obsolete within a handful of years. At which point, staying competitive means building or upgrading to the next generation of fab at a similarly enormous cost, all over again. For a company that both designs and manufactures its own chips, this creates a brutal ongoing commitment. Every design decision has to be made with the knowledge that the factory behind it needs to keep being fed with enormous continuous capital investment just to remain viable, regardless of whether that particular product generation sells well. If a company's chip designs stumble in the market for even one or two product cycles, the fixed cost of its fabs doesn't go away. The company is still on the hook for maintaining and upgrading factories built for a much larger volume of chips than it's currently selling. This is the trap that eventually made the fully integrated model increasingly difficult for smaller and even mid-sized chip companies to sustain. The cost of staying at the manufacturing frontier was rising faster than most individual companies' product revenue could reliably support. At the same time, a different kind of company was emerging, one that had brilliant chip designers but no interest in, or no ability to afford, building and running its own fab at all. These companies became known as fabulous chip designers. They had the engineering talent to architect powerful, innovative processors, but they had nowhere to actually manufacture them at a competitive level, because the entry cost of building a leading-edge fab was becoming prohibitive for anyone not already established as one of the largest chip makers in the world. This is the exact gap TSMC was built to fill, and the way it filled that gap is the actual center of this story, more than any single fact about Taiwan or any single technical achievement inside a fab. TSMC was founded on a specific deliberate business decision. It would manufacture chips designed by other companies, and it would not design and sell competing chips of its own under its own brand. That sentence sounds simple, almost like a footnote, but it's the single decision that made everything else about the company's rise possible, because it solved a trust problem that no fully integrated chipmaker could ever fully solve for its customers. Think about what it would mean for a fabless chip designer to send its most valuable intellectual property, the detailed architecture of its next flagship processor, to a company that also designs and sells its own competing chips. Even with contracts, confidentiality agreements, and legal protections in place, that arrangement carries an inherent conflict of interest. The manufacturer sees the design in intimate detail, learns from producing it, and could, in principle, use insights gained from that process to inform its own competing product line down the road. A fabless company handing its crown jewel design to a competitor manufacturer is trusting that competitor not to benefit from what it learns, a trust that's structurally uncomfortable, no matter how good the paperwork is. TSMC removed that conflict by design, not by promise. Because the company doesn't sell its own branded chips to end customers at all, there's no competing product line that could benefit from insights gained while manufacturing a client's design. A chip designer working with TSMC isn't handing its intellectual property to a rival who might use it against them next year. It's handing that intellectual property to a company whose entire business model depends on being trusted equally by every one of its competing customers at once. This neutrality wasn't a side benefit of the pure-play foundry model. It was the whole point, and it's the reason multiple fierce rivals, companies that compete intensely against each other in the market for finished chips, can all rely on the exact same manufacturer without that shared reliance being a conflict for any of them. Once that trust was established, a second, quieter advantage began compounding behind it. And this is the part of the story that explains why TSMC's lead became so difficult for competitors to close over time, even ones with enormous resources. Every fabless company that brought its designs to TSMC added to the total volume of chips flowing through TSMC's fabs. And in semiconductor manufacturing, volume isn't just revenue, it's education. Every production run teaches the manufacturer something about yield, about defects, about how a specific process behaves at scale in ways that smaller volume manufacturing simply can't teach as fast or as thoroughly. A fab running enormous volumes of diverse chip designs from dozens of different clients accumulates manufacturing knowledge about what goes wrong, how to fix it, how to push yields higher at a pace that a fab serving only its own, narrower internal product line cannot match. This created a reinforcing loop that's easy to underestimate in hindsight because it looks obvious now, but wasn't obvious at all when TSMC was a much smaller player competing against giants. More fabless customers meant more manufacturing volume. More manufacturing volume meant faster accumulated process knowledge and better yields. Better yields and process knowledge meant TSMC could offer more reliable, more advanced manufacturing than competitors, serving a smaller or narrower set of clients. That advantage has attracted still more fabless customers, including ones who might otherwise have considered building their own fabs or working with a competing foundry. Each new major client didn't just add its own order to the pile, it made TSMC's underlying manufacturing capability measurably better for every other client already there. In a way, a design win at a traditional integrated chipmaker never could, because that improvement was locked inside one company's product line instead of being spread indirectly across an entire ecosystem of independent designers. It's worth pausing here to be precise about what TSMC actually contributes to a finished chip and what it doesn't, because it's easy to blur this in a way that overstates the company's role. TSMC does not design the architecture of a customer's processor. Apple's design team, not TSMC, decides how many cores a chip has, how its cache is structured, what specialized circuitry it includes for a particular task. TSMC's role begins after that design exists, translating a customer's architectural blueprint into an actual physical manufacturing process, determining precisely how transistors will be laid out and built on silicon using TSMC's own process technology, then running that process at scale, wafer after wafer, to produce working chips that match the design specifications. This is a genuinely different function from design, requiring a completely different body of expertise. And it's exactly the function that fully integrated companies used to assume had to live inside the same building as the design team. TSMC proved that assumption wrong, but only by becoming extraordinarily good at doing that one function at a scale and reliability level that made outsourcing it a competitive advantage rather than a compromise. This is also the right point to draw a clear line between TSMC and the earlier chapters of this story involving companies like ASML. ASML builds the machines, the extraordinarily complex lithography systems capable of printing the patterns that define a chip's transistors onto silicon. TSMC doesn't build those machines. It buys them in enormous numbers at enormous expense, and then operates them at a scale and consistency that turns cutting-edge machines into a reliable, repeatable manufacturing process capable of producing chips for dozens of demanding clients simultaneously, each with different designs and different specifications. ASML sits one level below this story, providing an essential input. TSMC sits one level above it, turning that input, combined with an enormous amount of its own accumulated process expertise, into the actual product the rest of the technology industry depends on. Confusing the two roles misses what makes each company's position distinct. One sells the tool, the other has built the trust, the volume, and the operational mastery to use an entire fleet of those tools better than almost anyone else on Earth. The consequences of this model rippled far beyond TSMC's own balance sheet, and this is where the story becomes less about one company's clever strategy and more about how an entire industry reorganized itself around that strategy's success. Once a credible, trusted, high-volume foundry existed, the barrier to becoming a competitive chip designer dropped sharply for companies that previously would have had no realistic path to the leading edge of semiconductor manufacturing. A startup with brilliant chip architects but no capital for a fab could, at least in principle, design a competitive processor and have it manufactured by the same company producing chips for some of the largest technology firms in the world. This didn't just help a handful of already large fabless firms like Qualcomm or Nvidia. It changed the calculus for chip design as a business category entirely, making it possible for specialized, focused design companies to exist and compete without ever needing to solve the manufacturing problem themselves. But this same concentration of trust and capability carried an unavoidable cost, one the industry has become increasingly aware of in recent years, and it's worth stating plainly rather than glossing over it. As more and more of the world's fabless chip designers converged on the same trusted manufacturing partner, an enormous share of the planet's most advanced chip production became concentrated not just in one company, but largely within one geographic region. That concentration made a huge amount of economic sense from a pure efficiency standpoint. It's exactly the same logic that drove volume toward TSMC's fabs in the first place, where the highest concentration of manufacturing expertise attracted the most customers, which then deepened that same concentration of expertise further. But efficiency and resilience tend to pull against each other, and a global technology industry that depends this heavily on a small number of facilities in a specific region for the most advanced chips on Earth carries a structural fragility that didn't really exist under the older, more fragmented integrated manufacturing model, however inefficient that older model was in other ways. It's also worth resisting a temptation that's easy to fall into when telling this story, treating TSMC's position as an absolute, permanent monopoly on chip manufacturing in general. That overstates the picture. TSMC dominates specifically at the most advanced, leading-edge process nodes, the manufacturing technology capable of producing the smallest, most powerful, most efficient transistors currently achievable. There remain other foundries and other integrated manufacturers producing enormous volumes of chips at less advanced, but still economically vital, process technologies for products that don't require the absolute cutting edge. And building a new fab, while enormously expensive, is not physically impossible for other companies or countries. It's a matter of capital, time, and accumulated expertise, all three of which competitors and governments are actively investing in precisely because the concentration this story describes has become a recognized strategic vulnerability rather than a hidden one. What makes TSMC difficult to displace quickly isn't a legal monopoly or an unbreakable patent. It's the same kind of structural advantage that showed up earlier in this cluster of stories about the semiconductor industry, a lead built not from any single breakthrough, but from decades of accumulated trust, accumulated manufacturing volume, and accumulated process knowledge, reinforcing each other in a loop that took years to build and can't be shortcut just by spending enough money fast enough. A new fab can be built in a few years. The kind of trusted, high-volume, deeply experienced manufacturing relationship TSMC, built with dozens of competing chip designers over decades, cannot be manufactured on the same timeline. No matter how large the check, step back, and the actual shape of this story isn't really about Taiwan, and it isn't really about any single chip inside any single device. It's about a decision to give up something an entire industry had always assumed was necessary. Owning your own factory, competing directly with the value of what you produce in exchange for something that turned out to be more valuable in the long run, being trusted equally by everyone. TSMC didn't win by outcompeting other chip designers. It won by refusing to become one, and by turning that refusal into the reason the rest of the industry's most ambitious designers had no better option than to build with them,